That being said, let me now move over to our webinar for the day. As I mentioned, it's about containers. We're going to talk about Dockers. We're going to talk about Windows. We're going to have a couple of different demos to show you. This is going to be a great webinar. And on top of that, I believe everyone who attends today will be given a link for a free hands-on lab where you can play totally within a web browser, where you can set up and use and as well as take down Docker containers within a Windows environment, both Nano Server and Windows 10 desktop as well. So there's a little extra gift for those of you who attend today. With that being said, though, let me also now introduce our panelists for today. First of all, I want to introduce Blaze Stewart. Blaze is a senior consultant over at Wintellect, one of our presenters today. And Blaze, thank you for joining us. Just doing a little sound check, make sure you're hearing me.
Hey guys, this is Blaze.
Great. And Blaze is joined by Dan Stoltz, IT Pro Guru. And Dan is Chief Technology Strategist for the U.S. Northeast audience. He blogs over at itproguru.com. And Dan is with Microsoft, who we're very happy to say is the sponsor of today's webinar. Hey Dan, thanks for joining us today.
Hi, thanks for having me. Appreciate being here.
Okay, our sound checks look good. I think we're ready to take it away, guys. Dan, you're going to lead us off?
Sure. Greetings, everybody. Welcome. I'm going to start off with giving you a quick overview of containers and container services. So what is a container? And by the way, we're going to kind of start off with a real quick overview, and then we're going to drill deeper and deeper into it, so that regardless of where you are with understanding the technology, you can kind of catch up to the more advanced stuff we're going to talk about later on today. So you know, what is a container? Anytime you're doing compute, you have hardware, operating system, and application. In a traditional virtual machine environment, you're really looking at hardware virtualization. That is, all the applications and all the operating systems are not shared, right? So what you're virtualizing is the hardware. That's the shared component. And as we move further into containers, you still have hardware, you still have OS, but the OS is actually shared. So what you have is operating system virtualization. And the kernel and the application sit on top of the operating system. You can also split the applications, which give you an isolation container to run your applications. And we'll talk about some specific use cases later on in the presentation as we talk about cloud-enabled applications. Within the Microsoft stack, there are a couple different ways to run containers. One is the Windows Server container, which gives you the capability of maximizing speed and density. So you still have a shared kernel, but your application is running on in isolation. So you have isolation between them. It's very, very fast. And then we also offer Hyper-V containers. This gives us isolation plus a performance boost because we're not using a shared kernel. That obviously means it requires more resources to run, so it's not quite as slim as server containers or other container offerings that we'll talk about as we move deeper into the platform.
Yeah. Let me on the isolation scale. What we're talking about here is the level of isolation between various aspects of a particular deployment option that you might have, and going from left to right, you have physical, virtual, paravirtual containers, and shared hosting. Now, on the far left, you're going to have higher cost and more management involved in that environment. And as you move more to the right, what you're going to see is lower costs and less maintenance. That's because most of what's happening in a shared environment or a containerized environment is that is a managed platform, and all you're really concerned about is the application that is running in that environment. So with a container, you kind of get the best of both worlds. You can actually kind of provision the actual operating environment, not so much the operating system, but the operating environment with the libraries and all of the dependencies that you need to run your application, and provision that part, and then deploy it on a shared platform but you don't have to worry about any of the underlying components that would be that an operating system or the hardware or the patching of that hardware or the patching of that operating system and all of that which is involved there. So you have the high level of isolation that you get with shared like a virtual machine, but you get the shared experience that you get like a shared hosting environment and so forth. And on container, this isolation gives you an advantage as far as security is concerned too, because one of the cool things about containers is because of anything of the processes that are running inside of a container are isolated from every other process that's running on that same platform in other containers or even the underlying operating system itself. So it has a high level of isolation within that respect. So they did some research, the NCC group did some research on this, and what they found that containers offer a real advantage in securities because you not only get the level of isolation you get like what you would get with a virtual machine, but you also get a smaller attack surface on that particular container because you're not exposing an entire operating system to an outside world. So you're only exposing the application itself. So you reduce the footprint of the attack surface and you get isolation that you wouldn't otherwise get with a shared hosting environment. So what this does is gives you actually better security than what you would get with a virtual machine and what you would get with a shared hosting environment. So it's kind of the best of both worlds when it comes to security as well.
When we talk about containers, you'll hear a lot about the term Docker. So let me kind of explain to you a little bit about what Docker is. Docker is a company who built a product to manage containers. They're not the inventors of containers. Containers have been around for a very, very, very long time. But Docker did some pretty amazing things because they created a repository, a store that you could go and download public containers and the broader community could contribute a number of different kinds of containers or container objects. And we'll talk later about the way that is done. It could be done via a script. It could be done via downloading an image. It could be done by composing an image based on a configuration file. And what's happened here is Microsoft and Docker have partnered to really bring a very robust Dockerized application platform into Windows Server. And they've offered that in the two different ways that we talked about, Windows Server containers and Hyper-V containers. But they're also available, these apps are also available in Linux, and that's really where the big boom started on the containers and the images. The big beauty of this, though, is that these containers can be deployed anywhere, exactly the same from the location that they are today to the location where they're going, whether that's on Microsoft Azure, a service provider, another cloud provider, customer data center, wherever you run it, it's going to run exactly the same. So, you know, in addition to the enormous amount of open source development that's taking place, we also have companies that are leveraging containerization to bring to market very easily without customers having to do a lot of configuration because it's already configured on the container itself. And then whenever you think about from a DevOps standpoint of the developers being able to deliver an entire solution to the operations guys to actually deploy, you don't have any of these concerns around, you know, the developer didn't include a DLL in a package or anything like that, because all of it, everything that they've been working on is inside the container, and all of it gets migrated at the same time. So this strategic integration and investments between Docker and Microsoft really give us a very robust solution and some amazing capabilities that we didn't have otherwise.
When we're talking about what problems that Docker is really trying to solve, and Dan's alluded to these already, there's really kind of two things that Docker is really getting at. They want to enable DevOps, and they also want to support microservice architecture. And by enabling DevOps, that's, we know that DevOps is this kind of the synthesis of, if you will, of operations and development into a continuous cycle where where there's tight feedback loops and an environment of trust between operations and developers, and that whole process. And I won't go into too much detail about what that actually entails, but what containers do, though, is gives you the ability to kind of decouple a lot of the underlying infrastructure from the applications themselves, so that you can create a touch points, lightweight touch points between the applications and the underlying infrastructure. So this allows both sides to be rather agile in their operations and the deployment of software. And the other thing is microservice architecture. And microservice architecture, if you're not familiar with that concept, is really what you're doing inside of an application. Is the desire is to break the application into multiple independent pieces, and each one of these exists independently of one another and can be managed independently of one another. And then when you build a composite of all these various services, you create an application. The slide on the bottom right here is illustrating that, where you have various services, and that service might be a database, it might be a web server, it might be a cache server, it might be a web front-end, it might be a back-end service, it might be a mail agent. But all of those components working together in a unified fashion is really what creates the application. So this creates the ability to replace and swap out any one of those components without having to do a monolithic install of something. So it minimizes downtime, it gives you high elasticity in depending on the component that needs to be scaled, and so forth. So this is really a scalable, very elastic type architecture that gives you lightweight touch points between all the other various components, but it scales very well as at the same time. And Docker, by design, is to enable these services to exist independently of one another on a unified platform, which is the Docker engine. And we're going to unpack what that is in just a second. So with the so we've introduced the idea of containers. We want to just briefly introduce ourselves. I'm Blake Stewart, obviously, and we're talking about containers today. I'm a senior consultant at Wintellect, and I've been with Wintellect for a while now, and my specialties are in containerization and web development and a couple other technologies, and I've principally focused on the container space at this moment in time, and how that works. So that's kind of what I've been developing, and been doing a lot of work with Microsoft on this as well.
And I'm Dan Stoltz. I am Chief Technology Strategist for Microsoft. I have a very popular blog, itproguru.com. So I hope you'll visit and maybe follow me. Also, I don't have my Twitter up there, but it's itproguru. Oh, it is up there next to my name. Right. And I've also authored the exam reference 7534. I'm one of the authors on that. And I've been very involved with technology for probably 30 years, and really, really happy to get the opportunity to share with you guys today. One of the things that we're going to be able to give you as part of this presentation is an awesome opportunity to get hands-on with containers in Windows Server 2016. So you can install the prerequisites for Docker on Windows 10, install Docker, install a Nano Server base image, which, by the way, we're going to be going through some of this stuff, but we're not going to go through it in quite the detail because we have this hands-on lab where you can walk through it yourself. So you can create containers with and without Hyper-V isolation. You can create layered containers, images from containers, and you can remove Windows Server containers and Windows Server container images by using Docker. And whenever we talk about Windows Server containers, Hyper-V containers, Docker containers, they're all the same. They're all managed with Docker. Docker commands are universal, regardless of whether you're running them on Windows, on Hyper-V containers or Linux containers. The Docker commands are exactly the same. On the Windows platform, you do get additional options, like for the additional isolation that we talked about with Hyper-V. but they are exactly the same. They're all Docker commands that you're running to manage. So I hope you guys will take the opportunity at the end of this presentation, or put it on your calendar for this weekend or early next week, to go ahead and go through this hands-on lab, because that's how you're really going to learn. I know 3 or 4 people on this call might really learn some great stuff today on this call, but you're not going to really get it to sink in until you get hands-on with it. So I encourage you all to do that.
So here we're going to talk a little bit more about containers and what these entail, and then go a little bit deeper than we've already done. The Microsoft container space, as Dan mentioned, there is an architecture here that isn't typically done with containers on the Linux environment. The main difference here that we want to illustrate with Microsoft containers is that architecturally, a pure Windows container looks very similar to what you would get in a Linux container. You have a host operating system and a kernel there, and then the container actually abstracts the operating system kernel, and then you have all your binaries and libraries running in the container itself, and it's using a kernel virtualization inside of the container. While with Hyper-V containers, what it does is it adds a kernel into the container so that everything is abstracted one more layer than what you would otherwise have with a traditional container running on something like Linux. So it's like what Dan mentioned earlier. You have a one layer of extra isolation. So if you're doing this with a traditional VM, you would have hardware, you would have operating system, and then you would have a hardware virtualization, and then you would have an operating system and then an app. With a traditional container, you would have hardware, operating system, kernel abstraction, then the app. And then with a Hyper-V container, you have hardware, operating system, operating system abstraction layer, and then you have another operating system abstraction layer within the container, and then you have your app. So it's just one layer of extra isolation that you get, but it does actually give you a little performance boost and a few other benefits, and for even more isolation if your environment requires it.
Now, I'm going to dive in a little bit deeper and kind of show this, a lot of the same stuff, but in a different way, because the way that I want to show it is as a comparison to other technologies, like virtual machines or session-based computing, also known as terminal services, or VDI, and kind of show the difference between those technologies, because some people might be thinking, well, this is just a VM, right? Well, it's not, and I'm going to show you why it's not. And I'm not saying VMs are going away, because they're not. There's clear places for VMs, but there's also a very clear place for containers. Well, containers will give you a better solution. So first of all, session-based computing. What you have is you have the hardware, you have the hardware virtualization, you have the operating system, and then you have your applications installed. All of that is on your base machine, and then the users connect and use all those applications. They use the operating system, the same operating system, right? So you have one virtualization stack, you have one operating system, one installation, one set of maintenance for all of your applications. So maintenance is really easy, but the applications that you run, they often do have to be somewhat different, or at least the licensing is different because it's running in a terminal type of environment. And all users see and access the same OS, the CPU, the memory, the apps, etc. There's really no overhead to this environment, versus whenever we look at it from a VM standpoint, a VM or VDI-based standpoint, you have the same stuff. You have a hardware virtualization, the operating system, but then you have a split there, and all of that then splits off, because then you have another operating system inside of a virtual machine, and that operating system has its own apps, and then the users are connected to those applications inside that isolation container. So you end up with more isolation, but you have a huge overhead cost, because you have OS apps configuration management for each application or each workload. even though you do have that additional isolation. The cost is in in the management, in the licensing, in the disk I/O, and let me really tell you how big of a difference that is. It really is massive, because if you just look at it from a disk or disk I/O standpoint, from a disk capacity standpoint, you have to have an OS for each one of the workloads that are running. So on a reasonably sized data center computer, where you could easily fit 250 or even 500 users, or 500 what I'm going to call workloads in that environment, you're going to get 1/5 of that whenever you move into virtual machines, and you have an OS running for each of those. So you not only have to deal with the massive additional licenses, but you also have to deal with the operating system and the operating system I/O. Operating systems, especially Windows, whenever it's not doing anything, it's actually doing a lot, and that a lot, and also when it's running applications. You think about Outlook or any other application that might be running on there where it's doing a lot of disk I/O. You have that multiplied by all the different machines that are running that. So your disk I/O is just massive, and you can't fit even a large portion of the amount of workloads in that environment that you can in a session-based computing. So how does that relate to containers? So in a containers environment, you basically have the same setup, right? You have hardware virtualization. You don't have to have the hardware virtualization, but you can. Then you have this other layer sitting on top of it, this container image. And then on top of the container image, you have a container base image. If we build that out, you have an application which is using the same OS for all workloads. So you have isolation per application container, and you can fit a whole lot more apps on that, a whole lot more workloads, because you're sharing that operating system. Okay, so you don't have an operating system for each container. You have one operating system for all the containers, which is very similar to session-based computing. But you can, however, run container image and application workloads, multiple ways on a single host. So you can run the container image right on top of your operating system, but you can also add a virtual machine to that, and that virtual machine doesn't even have to be the same. It could be a Linux VM or whatever, and then run the container image engine on top of that with your container base image to run additional workloads. So in this scenario, you have an OS per platform, but isolation for each application container. So in either case, this is a case where we're using virtualization in a VM to give us additional capabilities on a single box, and give us that great isolation with also not having the overhead of running an operating system for each workload. So this gives you advantages of the VM and the session-based computing capabilities, plus isolation with very, very little overhead. The overhead is going to be your container image, your base image that's running. So very little overhead, but you get all of the great features of session-based computing and many of the capabilities of VMs or VDI capabilities in your from your isolation standpoint. So let's look at how containers run, and what our different deployment options are for containers. So we know that we can run in a VM. So you can, on top of the operating system, you can run a virtual machine without containers at all. You can also run Windows Server containers on top of a container service that's running on your operating system on your host. And again, this hypervisor layer doesn't necessarily have to be there, but it can be there. You can also run Windows Server in a VM and run Hyper-V on that server, and then run containers, Hyper-V containers on top of that VM. Well, you can also run Windows Server containers in a VM. So you have the container service running in your operating system that is the VM, and then the container service running on top of that. You can also run Docker in a VM. You don't have to run it in a VM. You could run that based on the operating system directly as well, but I'm showing it here in a VM, and that gives me the capability of running Linux or Windows. So it doesn't matter what type of OS is running on this. You can still run the Docker engine to run containers on that platform. The next deployment option that I'll talk about is just simply Hyper-V containers, right, where that runs on top of your hypervisor. And we can go even further down the stack or virtualize more of the stack by going to Azure containers, also known as Azure Container Service or Containers as a Service, ACS. So Azure abstracts all of the host and virtualization and just delivers the container. It still runs, you still manage it running Docker commands. You still have all of the capabilities that you have on other containers. You still have isolation per container. You can still have different types of images that you're running for your containers. It's just all abstracted through Azure. So there's lots of different ways that you can run containers and how you can deploy them. But you can also run, I talked about Windows Server, but you can also run Windows 10 and also Nano Server. Nano Server is the new deployment option for Windows Server 2016. So let's talk just a little bit. I'm not going to go too deep on this just for the sake of time. I want to leave some good time for Q&A. But the Nano Server is a minimized deployment option of Windows Server 2016. You do have to install it a different way. It doesn't install directly from the operating system disk. You have to basically run the deployment. Instead of running it through the setup, you run it through a folder, a deployment folder, a Nano deployment folder on the OS media. But the full GUI OS, the full GUI is really for specialized workloads that need full, GUI capabilities. Then we have server core, which setup time is about 300 seconds. The boot time is about 85 seconds, and the disk space is about 5.4 gig. And the minimum for the full GUI is more like, I think it's like 8 or 10 gigs, something like that. But then once you add your additional components, it goes up from there. Nano, on the other hand, 35 seconds to deploy. A boot time is 9 seconds, and the disk space needed less than a half a gig. So literally you could, run 2 of these on a 1 gig USB stick. Yeah, 1 gig, that's the stick that everybody throws away because it isn't big enough to store anything on it. So the Nano is ideal for next generation application development, really for your cloud native applications. So if you, have we're not going to talk a lot about microservices, but as you start leveraging DevOps practices, which we'll talk about in a little bit, to create isolated, applications that are cloud native apps, Nano is a great place, or containers running on Nano is a great place to actually deploy those.
So Dan's talked a lot about the various deployment options and what you can do with that. Now I want to overview of the Docker tools that you can use to actually deploy containers with. Now the Docker tool set is universal whether you're running it on Linux containers or whether you're running it on Windows containers. So all of these will apply to any deployment option that you're using, whether it be on Azure Container Services or you're deploying it on Windows Server or you're deploying it on a Linux server. All these same tools are available to you on all those platforms, which makes the Docker environment very consistent across all deployment options. And mostly what you're going to be doing is running everything. You're going to be connecting to whatever the Docker engine is running on whatever host that's running that. You're going to be using a Docker client. Now the Docker client is a universal client that will connect to any kind of Docker engine. And the Docker engine, it has built into it a number of things that is used to construct images and run images, and also create clustering for that. So to build a Docker image, what you would do is you would actually use the Docker command line or the Docker, what they call a Docker file. We'll look at that in a second. And it peels it off a base image. Then it goes out there to Docker Hub, which is a repository, downloads that base image, and then adds to that base image additional software, and then deploys that to the Docker, to a local repository on the Docker engine running on a Docker host. And the Docker engine itself contains Docker run, which then you take that image and then it converts that into an actual container instance. So you can create multiple instances of a container from a single image. And then that is actually running on a Docker host. Now there's a few other tools that are built into that Docker engine. Docker Swarm is the tool that Docker deploys for clustering Docker engines together across multiple hosts. So you might have 2 or 3 Docker hosts that are running, and what Swarm does is it kind of creates an abstraction of those 3 hosts to make it appear as if it were a single host, and so you're interacting with a Docker cluster instead of just a single Docker host. And when you deploy a container to the cluster, it's distributed across that workload, so you get fault tolerance, you get redundancy, and a lot of other advantages that you otherwise get from a cluster. So these sets of tools that you can have with the Docker engine, Docker client, Docker hub, and Docker Swarm kind of create the core of the Docker ecosystem. And now there's some other tools that go along with it, and I want to mention those. That's Docker Compose, which is used to set up orchestration on top of the Docker environment. And then you also have Docker Machine, which is another tool that is used for creating orchestration depending on what Docker host that you're using under the hood there. And lastly, I want to mention the kind of one of the newest things that come out of the Docker world, which is Docker Data Center. And this kind of pulls all these other tools into a single deployed environment, which is what we call a managed containers as a service engine. It can run on Azure, or it can run on an on-premise setup. But the Docker Data Center gives you all these tools baked into a single stack, and also gives you a lot of additional tools for monitoring and management of that environment as well. So this is Docker Data Center is available on Azure. If you want to check that out, you can go out there and get the Docker Data Center from the template. And this is some of the commands you can use inside of the Docker file. We talked about the template that you use to deploy create images. Now, when you use the Docker client, you use a special file called a Docker file, and it uses all these directives. I'm not going to go into the details of what all these actually do, but this is a snapshot of what they can do. And the bottom line is what you do is you take a base image, you apply these commands to install additional software on top of the base image, and then provision that environment to run. And the from command is the one that you use to specify the base image, and then and all these other commands just simply use that base image and then builds additional layers on top of that base image as you build out the Docker file. And we're going to actually demo one of these in a minute. And so, Dan, if you want to hand me control, I'm going to do my demo and show you what one of these Docker files looks like, and then I'm going to actually do a demo on a Windows Server instance of Docker to deploy a Docker container to Windows. Let's see. You guys see my screen? Can you guys see my screen, or are we still looking at Dan's? All right. Now, what I have here is I have a Windows Server virtual machine running on my local box, and this is a virtual machine running on VMware. And what I wanted to do is use this. I've got everything already installed on this, so what I want to do is create an application, and then I'm going to deploy it as a Docker container. So first thing I'm going to do is I'm going to make a directory, call it Docker demo. Let's just do that. Let's say make dir Docker dash demo, and then I'm going to change to that Docker demo folder. And then I'm going to go .NET new-t web, and this is going to create a new .NET application, and then I'm going to .NET restore, and this is going to create a new .NET application. It's just using .NET Core to run an application. I'm going to open up this Docker file here to show you what it looks like. Notice that this is running from Nano Server image. This can actually use Nano Server image on top of Nano Server, which is kind of cool because it allows you to use the Nano Server image on Nano Server as well. You can also use this on top of a standard Windows server like I'm doing here as well. And what this is doing is it's actually creating, from this image, it's going to use the entry point command to set the actual execution point whenever this container launches. And this is just exposing, telling .NET what URL to use. This opens up port 80, and then this command actually copies the content to the image. So this is done right here. So I want to flip over and actually use this Docker file on this. So I'm going to go .NET publish, and that's going to push it to a publish folder. And then from that publish folder, I can take that compiled code and then deploy it into a Docker container. So as soon as that builds, it's going to take a second to build out. I'm going to go ahead and get this ready to go. I think I called it Docker demo. This is just the name of the entry point demo, a DLL that is compiled whenever you build the application out. So once this is ready, it's going to install a bunch of dependencies into that that folder. It's actually using Bootstrap and a couple other things that are clean in this particular demo here. So it created this folder here. I'm going to take this right here and copy that, and I'm going to CD to that, and then I'm going to save this file right here, save as, paste it here, and I'm going to call it Docker file into that folder that it was that publish folder that it created. And so now I've got everything go. I've created a new application. I have built that application, compiled it, and then published it. Now I'm going to do Docker build, and I'm going to tell it to build from this particular Docker file that I created here. I need to rename this. I renamed it the wrong thing. Docker file without the .txt extension. That's better. Now flip back over here and Docker build, and I'm going to call it, give it a tag name, Docker demo, and then I'm going to tell it to use no cache because I don't want to cache this particular image, and then I'm going to tell it to use the local folder as the build script. Oops. Scroll back down. Not tag name, should be tag right like that, and that's going to build the image from that Docker file that I just created. And you can see what it's doing now is it's actually uploading that Docker, all the Docker content to the Docker engine that's running locally on this box, and it's going to execute all the commands inside of that Docker file to build the image. And once I have the image built, I can use that Docker run to actually build the to deploy this image. So let's let this finish. And it should be still running it. There it goes. And so if I go Docker images, you should be able to see that Docker demo that I just created right there. So I'm going to go Docker run, and I'm going to tell it, give it a name, Docker-demo, and I'm going to use a port. This directive tells it to use port 80, and I'm going to tell it what image to use, Docker-demo, and then this is going to create a container running this particular, running the application I just pushed to it. And so once that spins up, you can notice here is now listening on port 8080. I'm going to open up a new command here, and I'm going to go Docker inspect to get the IP address of this this particular container, and then I'm going to pull it up in a browser, inspect Docker-demo, and this is the IP address of this particular container. And then if I launch Internet Explorer, if I go HTTP, and I'm running on port 80, so I don't specify the port, this should pull up the default page that this installs inside of this container. And there's the default page for this particular container that's actually running on the this particular server inside of a Docker container. So you can use Docker containers to deploy websites as well as many other things you would otherwise do in .NET. This is just the landing page that they do, and it's got just a couple things that are pre-built. I didn't build this, this is just the template. So that's my demo for how to deploy things from zero to app in literally 5 minutes. Let's make it. Okay, Dan.
Okay, so sorry guys, let me find my screen. And this is one of the resources on the resource slide at the end of this deck. Let's go to how to Docker create containers, change containers, etc. Because what I want to do is I want to kind of show you the basics of how to get started with Docker, because I actually give you the step-by-step instructions, the commands. So this is the command to run a container, but let's actually go to install. I guess I don't have it on there. Let me open up in another doc. Give me a second. Okay, so I can't put my fingers on it at the moment, so let me switch gears for a minute. One of the other things I wanted to show you was working with containers in Azure. And if I go to my Azure account, and if you don't have an Azure account, you can create a trial account. Just search on Azure trial. I think it's account.azure.com. And you'll see what I have here. I've got a couple machines that I have built. I have Ubuntu 16 DevOps, and I have a DevOps CONT 121. And you can get the IP address for those machines from here to actually RDP into it. Whenever you create the machines, and what that looks like is if you go here, click on the little hamburger icon, you can actually go to more services, and then you can filter, or you can just create new. And if you create new, you can go ahead and search. So if I wanted to do a Windows Server data center, I'm actually going to just do Windows and search this way. Okay, so now it's going to bring up a bunch of options for Windows, and you'll notice that one of them is Windows Server 2016 with data center with containers already enabled. So you can actually go ahead and deploy that from you can actually go ahead and deploy that from here, and it'll actually create the entire set in Azure, or the entire server already configured with Azure. So I'm not going to go through the entire process, but I'm going to step you through it quickly. Whatever, that should be fine. Username, whatever. Password, I better be good about this because I have to repeat it. Okay. Oh, come on. That's the problem with the complex passwords. Okay, and in my case, I'm going to use an existing resource group, but you could just create a new one. I'm going to put it in DevOps and pick a look. The location's automatically defined by the resource group, since I already had a resource group. Define the size that you want to create. I generally go with the DS2, but you could go with a smaller machine if you wanted to. It really depends on how many containers you're going to have running on the machine, on how big the machine should be. And then you can let it create the storage and the networking and all that stuff automatically. And notice it's creating a public IP address for me with the same name as the computer. And I'm going to say OK. And that's it. It's done the validation. Everything looks good. I can say go. And it's actually going to go out there and create that Windows Server machine with containers. So it literally is that easy to get started with Windows Server 2016. Data center and containers are already installed. But you can also, on Windows 10, install containers. And what I want to do is I want to show you kind of a shortcut for doing that. There's this Microsoft on GitHub, Microsoft Virtualization documentation that kind of walks you through the process of doing that. So if we actually just search on nested virtualization, and actually let me just add GitHub to that, and you'll get right to the documentation. So you can run with this one, or you'll see that there's other documentations out there that will walk you through that process as well. And this actually has a script in it that you can a PowerShell script in it that you can actually run the PowerShell script. You can pass some parameters. If you don't pass them, it will prompt you, or actually it will tell you that it needs it. It'll error out and tell you that it needs it as a parameter. Or you can modify the script to do other things. It checks all your settings to make sure that your settings are correct. So as an example, you can't have, the VM can't be in a save state. It has to be completely turned off. And if it's not, it will actually go ahead and stop the machine for you. You have to have dynamic memory turned off. And if you don't, it will actually automatically set that for you. The MAC address, it has to make sure that MAC address spoofing is not turned on. So there's a lot of things that have to be set up, and the easy way to do that is just kind of run a PowerShell script to do it on your Windows 10 box. Then, whenever you go to actually deploy it, and I haven't done it on this machine, but then when you go to actually deploy it, if you just click on your Start button on your keyboard and then X, you can bring up Programs and Features, which opened up in another window. So let me drag this over. So in your Program and Features, you can click on Turn on Windows Features, turn on or off Windows Features. Which opened in another window again. And you'll see that I actually do have Hyper-V enabled on this. You have Hyper-V enabled, so you have nested virtualization. So you don't need to do that for containers, but to actually deploy containers, there's yet another PowerShell script that you can run. But in order to run that, you have to have Hyper-V enabled, because it actually uses Hyper-V. What it'll do is it'll actually stand up a VM in your Hyper-V, in your local Hyper-V, that runs your Docker. So once that is done, you can actually go out into, let me just do Windows X again, and I can run PowerShell, or I can run a command prompt. I actually just switched machines, so I might be struggling with this a little bit. Okay, so you can run PowerShell or the PowerShell ISE. I actually want to run, I'm going to run the PowerShell ISE. But you want to run it as administrator, so right-click and run as administrator. And then you, from here, from an elevated prompt, then you have to run the commands to actually deploy Docker containers. or to enable containers on Windows. So if I go to let me bring my window over. If I go to install Windows containers, what I want to do here is kind of teach you how to fish, not just kind of walk you through the steps. Again, as you go through the step-by-step, you'll be walking through it, the steps manually. So you can go to Windows Containers Quick Start, which is kind of the best place to start. Or there's also hands-on with Windows Server containers in the registry. So if you drill down into that, it talks about containers and goes you to the Windows Server Container Quick Start. So it actually tells you the modules, or the how to install the modules, how to install the package by just running PowerShell commands. But you do need to do a force restart, which is why I'm not going to run it here and now, and actually I already have containers installed. And then you go ahead and configure the containers. So the instructions are really simple. You just follow them online. But again, I encourage you to walk through the labs that we're presenting to you first, so that you can kind of experience that in a lab environment with step-by-step instructions. And the last thing that I want to do is Docker run. I don't have Docker installed on this machine, sorry. So you can actually just run Docker commands from your PowerShell window and run just like you would on any other server.
So I'm sorry to interrupt, Dan, but I think that actually is something you get a chance to do in the hands-on lab.
Yes, it is.
We sent out the URL for. And just quickly, guys, look in your chat section, because Dan, I think we might have had a wrong URL within the presentation. The good news is it's actually an easy URL to remember. It's https://aka.ms/try-containers. But it's in the chat section. You could just click on it. But
okay,
sorry
great.
to interrupt you. Go ahead.
So let me actually just switch over. Move this out of the way. Get rid of all this jazz. And pull up the PowerPoint again. So let's kind of dig into DevOps a little bit. And I can't talk about DevOps without talking about this book. This is a must-read for everybody. It is a book put out by Gene Kim, and it is absolutely fabulous. In a kind of a novelish way, it walks you through the DevOps problem and the challenges that DevOps practices solve. So it's very interesting. The first couple chapters may be a little slow, so if they are slow for you, keep chugging on, because it gets very, very, very good. And there's also an audiobook available for it. The audiobook, hold on a second.
You can get the audio book on of Amazon.com, as a matter of fact, as well as the different versions of the Phoenix Project, Dan. And I just to even add a little bit more, of course, Gene and team have come out now with a new book, sort of not a sequel, but a companion to the Phoenix Project, and that's called the DevOps Handbook. It's written by Gene Kim, again, Jez Humble, Patrick Dubois, and John Willis. And next week, anyone in Seattle, we are doing our CD Summit DevOps Connect. We actually have someone from Microsoft speaking, one of the DevOps evangelists speaking on Docker and containers and DevOps. And we'll have copies of the books that we'll be distributing, as well as in LA the following week, where John Willis will be speaking and signing some copies. So
yeah, so maybe in the chat you can put some URLs up for that when you get a second.
Absolutely.
Awesome.
Jules or some of our engineers, if we could put some of the Amazon URLs as well as the URLs for the DevOps Connect events for people
Awesome,
interested.
great. So this book, if you haven't read it, you can get it on audiobook. If you don't have an account on Audible now, whenever you set up your account for the first time, you get 2 free books. So this could be one of them, and it really is a must-read. So a little more information about what's in the book. I'm going to kind of skip over this because we're running kind of late, and I want to reserve some room for some Q&A if possible. But you know, infrastructure as code, continuous integration, automated testing, application performance, continuous deployment, release management, configuration management. These are all fundamentals. You know, automated recovery, roll back and roll forward. These are all fundamental principles of DevOps. You know, Jim Kim refers to it as the first wave, systems thinking. The second wave, amplify feedback loops. And the third way is culture of continual experimentation and learning. So I've got a couple of URLs here for you to dig deeper into those. But by all means, please read the book and kind of get caught up.
Great. Dan, we just have another minute or two here, and we did have 1 or 2 questions. So if you want to wrap up.
Yeah, let me just share one thing. The difference between a monolithic and a microservices app, because as you start talking about DevOps, one of the clear things that you want to do is break open these giant apps that kind of do everything, and you break them down by application features, and those features are kind of standalone, and that gives you lots of other capabilities.
I've tried to go through the questions and answer them in the
I see. Yeah. I was noticing that, Blaze.
We were up against the time there, but I just wanted to, you know, if there was any other additional questions, please feel free to ask those. But I think I tried to go through the questions and type the answers out. So if you guys want to refer back to those, please do.
Okay, so the last thing that I have is just some great resources. So take a look at the links on the slides, you know, including both of our blogs, mine and Blaze's blog. Reminder about, and of course you've got the URL in the window for this. I think they probably go to the same place, but the other one's a lot easier to remember, and that gives us additional ways of knowing kind of how people learned about it. So additional homework: create a Docker account and link to it with Azure. Right? Create your WordPress site on Azure or in Docker container. Log in. Do some basic stuff to get used to the technology. I've got some free resources from DevOps practices. So lots of additional downloads that you can continue learning and continue reading. Most important, though, is going to be that hands-on lab. And you can also stay up to date with my blog and Blaze's blog. And in reality, though, I think Blaze and I are both working on a pretty detailed blog post on how to use Dockerfile for deployment. So, you know, we're both blogging about it all the time, and we've got some really good stuff coming up. So monitor them at least over the next couple of weeks, even the next month. Maybe subscribe so you don't miss out on some of that stuff. And with that, I will turn over to Q&A if we have.
Thanks, guys. I'm going to grab what we have here. First of all, before we do though, because we're already over time.
Oh, we are, okay.
Dan and Blaze, thanks so much. You know, Docker and containers and everything is so hot. And this hands-on demos like this, it's worth its weight in gold. Thank you so much for sharing this with our audience today. Just one, it's not even a question, it's a distinction. You know, containers that were set up on Windows and then moved to Linux and vice versa, there are some kind of gotchas and rules you need to follow. Anybody, Blaze or Dan, you want to mention or briefly talk about it?
The one thing you want to be careful about is, like, a Linux container can't run on a Windows host, and a Windows container can't run on a Linux host. They're specific because it's abstracting the kernel. Remember that. So it's a Windows kernel needs to run Windows app. However, most of the container environments, the Docker environment itself, will let you know if you do that. And Microsoft has done a good job of providing tools for running ASP.NET Core applications that will run on Linux as well as Windows hosts as well. So The main thing that you want to use Windows containers for are for Windows-specific applications that won't run on Linux, and vice versa. Linux won't run on a Windows environment. So just make sure that you're making sure that the operating system matches the container that you're deploying.
Yep. Excellent. So with that, the other one wasn't so much what are the additional capabilities. I don't know in relation to what. But I think we're going to call it. We're 2 minutes over time. We've got to be sensitive. I know there's 100+ people out there. But again, thank you everyone for attending. We hope you got out of this some really great information. And there was also a handout where everyone can download our new Containers and Security report, sponsored by Microsoft. And more importantly, go play with this yourself on the hands-on lab that Microsoft's made available. I'm not a pro developer or ops guy, and I was able to do it. It's worthwhile. I highly encourage you to do so. Until then, this is Alan Schimmel for DevOps.com. We'll see you on another DevOps.com webinar. Thanks, everyone, and have a great
everybody.
day.
Thanks.
Bye-bye, guys.